Thank you, Mike, and good evening. With clear direction from Chief Engineer's concept, we developed a performance strategy plan and worked with our engineering design divisions to achieve performance targets. Tonight, I would like to touch on several factors that define vehicle performance. Specifically, I will provide examples of power performance, vehicle dynamics, noise and vibration, HVAC performance, and safety. The new Sienna offers a choice of two powertrains. The 3.5-liter V6 engine, which was offered on the previous model, is now mated with a 6-speed automatic transmission. And new for this model is a 2.7-liter L4 engine. In the case of 3.5-liter V6 engine, through modifications of the intake and exhaust manifolds, we were able to increase mid-RPM torque, thus improving normal driving and passing conditions on the new Sienna. The 2.7-liter L4 engine provides a very flat torque curve with 90% of the peak torque available from approximately 2,000 RPM to 5,700 RPM. Simply stated, the L4 engine provides sufficient power for most minivan needs due to enhanced acceleration performance. The 6-speed automatic transmission is able to utilize the maximum performance of the engine by adopting closer gear ratio, which matches the engine output characteristic. Final differential ratio was chosen to provide the best balance of fuel efficiency and performance. Engine calibration was performed to improve the response of the vehicle via throttle tuning. This resulted in improved direct feel and controllability, thus making sure the vehicle's acceleration has a linear feel, no hesitation or jumpy feel. Let's now review the result of powertrain performance. The new Sienna with the V6 has best-in-class acceleration, and the L4 has a comparable acceleration performance. And even with this class-leading acceleration, the fuel economy is at the top of its class. The all-wheel drive system consists of electronically controlled coupling placed in front of the rear differential, the ECU controlling the coupling, and various sensors. The ECU receives signals from a variety of sensors and sends current to electronically controlled coupling in accordance with the situation. When accelerating or starting on a low friction surface, all-wheel drive torque is quickly generated, realizing superb acceleration performance. During average high-speed driving, torque is no longer set to the rear wheel, enhancing fuel efficiency. In addition, when the brake control systems such as ABS and BSC intervene, torque to the rear wheel is stopped to avoid interference with these controls. Upon cornering, transfer torque to the rear wheel is increased when approaching an understeer and reduced when approaching an oversteer condition. The new Sienna uses two control methods. One is feed-forward control, which is used to distribute torque in accordance with the driver's predicted target line through a corner. The other is feedback control to distribute torque after determining actual vehicle movement. Both controls enable outstanding cornering ability. The next few slides will focus on vehicle dynamic performance, starting with performance image. For comfort, we aim to improve ride comfort, avoid long trip fatigue, confidence in vehicle responsiveness. For convenience, ease of maneuverability exceeds expectation for all driving conditions, whether it is starting, stopping, or turning. And for cool, we offer chassis tuning that surpasses the traditional minivan image by offering performance and feature not available on the previous Sienna. Next, let me explain how we translated our image into vehicle dynamic targets. First, in terms of target setting, this graph depicts the ride and handling of the current minivan market using subjective evaluation method. We improved ride comfort and handling to make the new Sienna best in class for each while maintaining a good balance of previous generation. Excuse me. Talking too much. Next, I would like to give examples of how we were able to achieve our targets. The new Sienna's chassis dimensions were developed to accommodate new tire and wheel sizes and to maintain the target interior space and convenience. The tread is increased 55 millimeters in front and 20 millimeters in the rear, thus improving stability. The end result is wider, sleeker vehicle that is solidly planted on the road and can still turn on a dime. To improve handling and responsiveness through suspension and tire tuning, the lateral acceleration and roll angle are expanded above and beyond competitors. In order to continue providing convenience to our customer, our tire supply partner Bridgestone has developed an improved run-flat tire concept. This innovative concept uses cooling fin technology to reduce the heat generated at the low inflation and thereby allowing a lighter and softer tire design with improved fuel economy. You can stop by at the Bridgestone display later to learn more. Implementation of key underbody aerodynamics component has allowed us to not only improve high-speed vehicle dynamic behavior, but also lend their effectiveness in lower speed as well. These components include engine undercovers, floor undercovers, and spans. In terms of newer technology, the new Sienna offers first-in-class electric power steering EPS that is standard on all grades. EPS offers speed-dependent tuning of steering assist. With EPS system, we are able to custom tailor steering effort to match vehicle speed that feels more natural to the customer in a variety of driving situations such as parking, cornering, and a straight highway. In the case of lower speed, such as parking lot maneuvering, we were able to reduce the effort by about 36% compared to previous Sienna. The cornering performance can be demonstrated in the following video. This video shows a comparison of vehicle yaw rate versus steering torque. In these graphs, both previous and new Sienna have essentially the same yaw rate build, green bar and red bar. The key difference between the two vehicles is the rate of torque build, yellow bar and blue bar. On the upper chart, pay attention to how the previous Sienna maintains an early, low steering torque build with a quick ramp up at the end, while the next generation Sienna has a more steady, linear build, which matches more closely to the vehicle's yaw rate. Matching between yaw rate and steering torque is the key component of the feedback, which helps to suggest to the driver that vehicle movement is more accurately matching the steering inputs. And finally, at higher speed, EPS provides superb straight line stability, control, and avoid driver's fatigue on long drives. This can be shown by the following graph. The overlay of steering efforts graph for both previous and new Sienna shows that the yaw rate is more linear for new Sienna with almost no correction needed. This tends to feel more natural and agile, and hence easier to drive long distances. The following videos can demonstrate the difference between the two vehicles. Additionally, the EPS system employs three distinct features, namely flutter control logic to damp out any steering vibration caused by rotational imbalance at the brake or tire. Torque steer logic to help maintain steering confidence during situations such as launching on a split new surface and hard acceleration.